The iodine clock reaction, an interactive presentation by Tim Lyons. What is the iodine clock reaction? It's an experiment used to display chemical kinetics in action. It was first discovered by Hans Heinrich Landolt in 1886. It involves two colorless solutions being mixed together. After a short delay, the mixture suddenly turns blue. But why? The ingredients in this experiment are hydrogen peroxide, vitamin C, which is also known as ascorbic acid, iodine, cornstarch, and distilled water. As I said, there are two solutions involved in this experiment. We will call them solution A and solution B. Solution A consists of vitamin C, distilled water, and iodine. The chemical formula for vitamin C is C6H8O6. For iodine, it's I2, and of course H2O is water. Solution B consists of hydrogen peroxide, starch, and water. So that's of course H2O2 is peroxide, C6H10O5 is starch, and H2O is water. Both of these solutions are clear. Solution A contains iodine, which is a very dark brown color, but it turns clear as soon as it's mixed together with the vitamin C. So what is taking place in this experiment? There are two reactions taking place at the same time. The first reaction starts in solution A when it gets mixed, and it's a very fast reaction. It's converting iodine into iodide. So actually this is reversed. I2 is converted to I negative. It does this when we mix solution A, and then it does it again when we add solution A to solution B, because the second reaction involves H2O2, peroxide, converting the iodide from the first reaction back to iodine. This is a slow reaction. If it could keep up with the first reaction, there would be iodine in the solution and it would turn it blue. But it's not. It's a slower reaction. So what we see is a cycle. The vitamin C converts iodine to iodide, and then the peroxide converts the iodide back to iodine, and it runs in this cycle until the vitamin C is used up. At that point, there's only one reaction remaining, and that is peroxide converting iodide to iodine. And so we suddenly see iodine in the solution, and the solution very rapidly changes color and becomes blue. And if it sits for long enough, it will become that brown color of iodine. That's when the iodine clock changes and the solution suddenly turns blue. And you can see here 4 pictures from my experiment. This happened very quickly. I was stirring the solution for 4 minutes because I put apparently a lot of vitamin C into the solution. So it took 4 minutes for the vitamin C to all get used up. But as soon as it was used up, the solution turned blue within 2 seconds at the most. Probably even less than 2 seconds. It very quickly went from clear to light blue to very dark blue. In conclusion, the iodine clock demonstrates chemical kinetics. There are different reactions taking place in it at different rates. And different reactions in general take place at different rates. This is known as the reaction rate. Overall, balanced equations will show you reactants and products of a reaction, but they don't show you the intermediary steps and catalysts, such as we see here with the iodide in this reaction.